Hello, we're looking at problem number 3 from your Geometry Part 2 textbook. This is found on page 463 of your textbook. And what it's talking about here is how to use a geometric mean and set up a proportion the correct way when you have a triangle. One thing I want to bring your attention to is this over here, this area right here. And that is, you have to read in your textbook on the previous pages how to decide which one of the rules or corollaries that you're going to use to be able to find the altitude. You would use corollary 1, and if you're going to find a leg or a hypotenuse, you're going to use corollary 2. So if you look at the particular problem, it's wanting you to find x and y, and so to find x here, we're going to use, again, the idea of a geometric mean that 4 is to x. Now, if you'll notice, that is comparing a leg to a hypotenuse of this little triangle in the same way that we're going to compare x to the hypotenuse, which is this and this together, for the big triangle. So the short leg is to the hypotenuse of the small triangle as the short leg is to the hypotenuse of the big triangle itself. And so that's why they have 4 over x equals x over 4 plus 12, which again, that happens to be 16 there. Now, if you were to cross multiply here, 4 times 16, which is what 4 and 12 is, that's where they're getting the 64 right here. And then, of course, x times x is where they're getting the x squared. Now, once you have x squared equals 64, of course, you don't want x squared, you want x. So you're going to take the square root of 64, which, of course, is positive or negative 8. But since distance can't be negative, we only pick the positive, so positive 8. Now, if we're trying to find the y value, notice that the y value is the altitude. And according to this over here, we're going to use corollary 1. So we're going to say 4 is to y, which is the short leg to the longer leg, as the short leg is to the longer leg of the other triangle, not the whole big triangle, but the other triangle, this one right here. So 4 is to y as y is to 12. Again, if we cross multiply, y times y is y squared, 4 times 12 is 48. To take the square root of that, y equals square root of 48, and then remember that you're looking for the largest value that will go into that, which that breaks down into 16 times 3, and the square root of 16 is where they're getting the 4, and of course the 3 is not a perfect square number, so it stays under the radicals. That's where the 4 square root of 3 comes in. Now let's do number 3. If we were going to find x and y on this particular problem, again, x is a leg, so we're going to say 4 is to x, which is comparing, again, the short leg to the hypotenuse, as x is to the hypotenuse of the bigger triangle. So it's going to be x is to 9, which is the 4 and the 5 together here. So when we solve this problem and we cross multiply, that's going to give us x squared here, and 4 times 9 is 36. Take the square root of that, and of course x would end up being 6. Now to solve for the y, notice that the y is an altitude. So we're going to say 4 is to y there, as y is to the other leg, which is 5. Okay, we treat that differently because it is an altitude. The same kind of setup, but different. So you've got y squared, and 4 times 5 equals 20. 20 is not a perfect square number, so we have to find the perfect square number that will go into that, which is 4 times 5. The square root of 4 turns into a 2, so that ends up being 2 radical 5. And that's your y value there. Okay, so that's how you find your x and your y value. Hope this helps.